Hello, dear students. This is your science teacher, Mrs. Tasneem Atif, and I'm happy to be with you today. Today, inshallah, we're gonna explain a quick revision on our curriculum so that you can get the most benefit of it. So, let's start our revision. First of all, we're gonna explain Unit 1, Chemicals, and contains 3 lessons. Lesson 1, Metals and Nonmetals. Lesson 2, Alkaline Acids. Lesson 3, Chemical Evidence and Salts. Let's start first by comparison between metals and nonmetals. Metals, they are solid materials that can withstand the surrounding conditions. And also, it has metallic luster and it's a good conductor for heat and electricity. And also, it's affected by chemical reactions with other elements. What about nonmetals? They are chemical elements that mostly lack metallic properties. They are not like the other metallic properties. And physically they have low melting point and also low density. Nonmetals usually brittle in the solid state and have poor thermal and electrical conductivity. So, in this table, we will get the main points of differentiation or the points we can differ through them between metals and nonmetals. First, metals, their outermost energy level should contain 1 or 2 or 3 electrons. Nonmetals, they contain 5, 6 or 7 electrons in their outermost energy level. Point 2, all metals are solids except for mercury, which is liquid form. What about nonmetals? Nonmetals exist in solid and gaseous state except for bromine, which exists in liquid form. So the only liquid metal is mercury, while the only liquid nonmetal is bromine. Point number 3. Metals, they have metallic luster, while nonmetals, they don't have metallic luster. The next point, metals such as sodium, copper, zinc, and silver, they have metallic luster and are ductile, malleable, and formable. While nonmetals, they don't have metallic luster and they are brittle, such as carbon and sulfur. Next, metals are good conductors of electricity. Nonmetals are poor conductor of electricity, except for graphite. Metals have high melting and boiling points, and of course they can conduct the heat well, while nonmetals, they have relatively low melting points and are poor conductors of heat. Root and attraction ability. Metals turn into sheets when harmed, as you can see in the following figures in front of you. So once we harm the metals, they turn into sheets or then they turn into wires when drawn because the ions slide easily on top of each of other. Okay, let's fast forward for the next point. Metallic bond. What is the meaning of metallic bond? Metallic bonds explained by the atoms of the solid metal are arranged in arrangement known as lattice crystalline metal and is in form of cations. Surrounding has a cloud of freely moving valence electrons. The term expresses metallic bonding is the force of attraction between positive ions and the cloud of negative valency of electrons that surround it. So again, What is the meaning of metallic bond? It is the force of attraction between positive metal ions, or what we say cations, and the cloud of negative electrons of valency surrounding it. Okay? That's a proof for the melting points of metals. As for example, we will mention the metal and its melting point. Sodium, its melting point 98 degrees Celsius, while magnesium 650 and aluminum 660. This is due to the availability of more electrons in the outer level in case of aluminum. So the metallic bond here increases according to the electrons that are available at the outermost energy level. Metallic bond, the greater the positive ion charge, the stronger the metallic bond. The smaller the positive ion, the stronger the metallic bond. The more decollized electrons, the stronger the metallic bond. So that's all about the cations or positive ions and the cloud of negative electrons according to the valency. Metals are good conductors of electricity because they have delocalized electrons. Delocalized electrons can carry a charge when an electric potential is applied across the metal lattice. And then they move toward the positive terminal. A negative terminal produces more electrons. Metals are usually better conductors of electricity when they have a lot of delocalized electrons. Aluminum is better electrical conductor than magnesium according to the valency cloud of electrons, and it's a better electrical conductor than the sodium. So magnesium has higher conductor property than sodium. What are alloys? Pure metals, they are soft and often unsuitable for industrial use. So one or more molten metals are often added to another molten metal. Why? To form what are known as alloys, whose properties differ from the properties of elements that make them up. Alloys, mixtures, most of them are not expressed in molecular formula. Alloy bronze, it is one of the most famous alloys used to manufacture of jewelry, medals, and statues. It consists of copper by 95% and tin only 5%. The bronze alloy is characterized by being harder than copper and not susceptible to rust. It's widely used in industries such as wire making and nail making, and the commercial bronze doesn't spark. If you hammer it with steel, it's used in the manufacture of slides and hammers, and also it enters in manufacture of tools used under harsh conditions such as flammable vapors and explosive atmospheres. Live application, the process of converting waste into new usable materials is known as recycle. Some metals such as copper, aluminum, and iron are recycled for the following reasons. The following three reasons. Number one, decrease in the presence in the earth. Number two, difficulty in extracting it of its raw metals or materials. Number three, the cost of recycling is lower than the cost of producing it from its raw materials, like this one. That was the end of our first lesson, and see you soon in lesson two. Goodbye.